Hi, this video will talk about how to rationalize radical expressions. Specifically, we are going to target rationalizing the denominators. Now, this topic came into place because there are results after division of radical expressions where the denominator still contains irradical expressions. In mathematics, we need to somehow remove or neutralize the radical expressions that are found in the denominator. Hence, the topic rationalizing denominators. Well, rationalizing can also be done in the numerators, but our main goal here is just to rationalize denominators. This is still part of lesson number 3, which is on multiplication and division of radicals of our unit 3, the radical expressions. Why it's still part of the multiplication and division of radicals? Because again, I would like to emphasize, rationalizing denominators came into place because there are results in the division of radical expressions where the new denominator still has radical expressions. Let me show to you a practice exercise here, or some items that are not actually new to all of us. If you have seen the previous video, you were actually going to notice that items 1 to 4 here are results of the practice exercise B, commonly focused on the division of radicals or radical expressions. So at that time, we still accepted these expressions as our final answers. But since we are now going to rationalize denominators, we are going to simplify them further. Again, the term is rationalizing the denominators. We can, in simpler language, we are going to omit, remove, or neutralize the radical expressions found in the denominator. So it would be very okay if there are radical expressions found in the numerator, but as soon as we will notice that there are radical expressions in the denominator, we need to rationalize them. Let us start by having number 1 as 1 over the square root of 3. Again, our goal here is to remove the radical expressions in the denominator. So to rationalize the denominator, we are just going to simply multiply the given by 1. We are going to simply multiply the given by 1. But of course, this is still part of the identity property of multiplication, wherein any number multiplied to 1 is the number itself. It's not necessarily 1, but we are going to multiply here a value which is just equal to 1. Okay? That's the first thing. We are going to multiply here a value which is just equal to 1 so that we are not actually changing the given. But what item equal to 1, or what expression equal to 1 we are going to multiply here? Take note that the radical expression of the denominator is square root. In short, we are going to multiply the denominator also with the square root, because we are following the concept of multiplying radicals, or multiplication of radical expressions, that you can only multiply radical expressions if you have the same indices. In short, we are going to use square root. And we need to place here a radicand, wherein as soon as we multiply it with square root of 3, this can be simplified under square root. So what number is that? We could actually choose here square root of 3. Why? Because square root of 3 times square root of 3 will become square root of 9 and can still be simplified further. Okay? Now, I have mentioned earlier that we are going to multiply here an expression equal to 1, not that 1, okay? Because this is not equal to 1. An expression, or specifically a rational expression, or expression in a fraction form, it can only become a equivalent to 1 if the numerator is the same as the denominator. In short, we are also going here to write here square root of 3, because square root of 3 divided by square root of 3, it's just equal to 1. And 1 times the given is the given in itself. In short, we are not changing the given here. And we use square root of 3 because that's our target for our denominator. Now that we have this multiplier here, let's try to multiply. So 1 times square root of 3, that's for your numerator. And you have here square root of 3 times square root of 3. So this becomes 1 times square root of 3 is square root of 3 over the, please review how do we multiply radical expressions. We copy the radical expression because we have the same indices and we multiply the radicands 3 times 3, which is 9, which is again later on equivalent to square root of 3 over the square root of 9, which is 3. This is the other form of the given expression 1 over square root of 3. But since we are now rationalizing, this is what will be more acceptable than the given earlier. Don't get me wrong. This is still equal to this value. In short, they have the same value. But for proper presentation of radical expressions, make sure that the denominator doesn't have any radical expression. That's why we rationalize it into this given. Okay, so let's take number 2 as our part of our understanding. Square root of 2 over 4 square root of a. When we are going to rationalize the denominators or radical expressions found in a denominator, we are just going to concern with the radical expression of the denominator. In short, we don't need to multiply here something that contains 4. Let's just focus on the radical expression square root of 9. Okay? And also, our goal is to rationalize denominators. Let's not be concerned with what is present in the numerator at first. To look for our multiplier, we simply are going to multiply this by the same radical expression here, square root of a. Right? Do not, you may include 4 if you want, but later on it will just be simplified further. No need for that. Okay? In the numerator, okay, if you will say I will also multiply this here by square root of 2 because they have the same, take note that this multiplier is not 1. Again, we are just going to multiply the given with 1 or an expression equal to 1 so that we are not changing the given. We are not manipulating the value of the given. So what we are going to place here is actually still square root of a so that they are still equal to 1. So let's proceed. You have negative times positive. Rule of signs for multiplication, still negative. And then you have square root of 2 times square root of a all over 4 square root of a times square root of a. Further, you have negative square root of 2. Okay, how do we multiply radical expressions? We copy the root or the form of the radical expression, in this case square root, and then we multiply the radicands. That's 2a all over 4 square root of a times a is a squared. And then we simplify the denominator. In the numerator, we can simplify this because 2 and a, neither of them are for perfect square factors. So you just have 2 square root of 2a all over 4 square root of a squared is a. So this is the other form of the given for number 2. Okay. So take a look at the answer. No radical expressions in the denominator. That means we already rationalized the denominator. Let's proceed to number 3. Number 3 now is concerned on a cube root. Cube root of 2x over cube root of y z. So we are going to multiply here an expression equal to 1 in rationalizing. But since we have a cube root here, we will also be using cube root as our multiplier. Earlier, we used square roots and square roots because numbers 1 and 2 are both in square roots. Okay, so if this is cube root here, we're also going to use cube root in the numerator. So what will be our multiplier here? Some of you might say, sir, we will use yz, just like what happened in number 1, we have the same radicand, and number 2, we have the same radicand. So we are going to use here yz still. But if you're going to multiply this, you have cube root of, that becomes y squared z squared. Can y squared and z squared be simplified using cube roots? Or simple, is y squared z squared, or any of the terms or both of them, perfect cube? The answer is no. They are just perfect square factors. So it's not actually y and z as a radicand here. So we are going to look for a value of the radicand that when multiplied here in the given can be simplified using the given root. Okay? In short, we are going to use, sorry, we are going to use y squared and then z squared. So that when we multiply y squared and y, it becomes y cubed, a perfect cube. And when we multiply z squared to z, that becomes z cubed, a perfect cube. Both of them can now be simplified using cube root. So whatever is placed here, so that we will have an expression equal to 1, copy. And then let's proceed. So you have cube root of 2x, y squared, z squared. We can simply multiply them because they have the same indices, all over cube root of y cube and then z cube. And then we can now simplify the denominator. In the numerator, take note that it's a cube root. 2 is not a perfect cube. X is not a perfect cube, nor y squared, nor z squared. Therefore, we cannot simplify any of the items in the numerator. But we can simplify the items in the denominator. Cube root of y cube is just y. Cube root of z cube is simply z. Okay? So this is the simplified form when we rationalize the denominator of number 3. Let us have our last item. Last item is concerned on 1 over the sixth root of 2. Again, the denominator has a radical expression with index 6. So we are going to look for any factor that can be multiplied to the sixth root of 2, which will create a perfect 6 number. So it's still sixth root here and sixth root at the numerator. If we will use 2, 2 times 2 is 4. It's not a perfect 6 number. 3, 2 times 3, it's not a perfect 6 number. It's just 6. It's not perfect 6. Else, 4, 8 is not a perfect 6. You look for the values. Okay, the value that needs to be multiplied here is 32, because 32 is a perfect fifth number. It's the value when we take 2 to the power of 5. And then when we multiply this 32 by 2, it will become 64. And 64 is actually the sixth power of 2, because 2 times 2 is 4, times 2 is 8, 16, 32, 64. So 64 now is a perfect 6 number. So what we use here is 32. We'll also copy 32 here. And then simply multiply. 1 times 6 root of 32 is just simply 6 root of 32 all over 6 root of 64. Very far. 6 root of 64. Again, the denominator can now be simplified. So you have the final answer here as 6 root of 32 all over 2. This is the equivalent value when we rationalize 1 over 6 root of 2. Okay? So again, we need to look for the factors which can simplify the radical expression when we are taking the product of the values. Okay? So you could use this video for your practice later on for our all other examples. Here we just simply use the products or the outcomes of the practice exercise B for a division of radical expressions. We will have another part of rationalizing denominators, which will be concerned on a denominator in binomial form. In this video, we talked about 4 examples wherein the denominator is only in monomial form, or simply one term or single term. In the next video, we will talk about how to rationalize uh, radical expressions with uh, a binomial or two terms in the denominator. Hopefully, you've learned something. Please review and enjoy solving radical expressions. Goodbye.